electric flux and field intensity. It is of course possible to draw a line of force through every point of an electric field, but if this were done, the whole space would be filled with lines and no individual line could be distinguished. By suitably limiting the number of lines in space, the lines can be made to indicate the magnitude of field at a point. This is accomplished by spacing the lines in such a way that their number per unit area, cutting a very small surface held perpendicular to the line of force at a given point, gives the electric field at that point. The total number of lines of force crossing a surface normally is called flux. On that surface, the flux per unit area or flux density at any point gives the electric field at that point. The flux at a surface is determined by the product of flux density, that is, electric field, and the projection of its area perpendicular to the field. By the product of area and the component of field normal to the area for a very small plane area delta A, such that the field at all of its points is the same. The flux is given by the flux delta Q is equal to delta A is equal to E dot delta A. The flux is a scalar product of electric intensity E and vector area delta A. Although area is a scalar quantity, delta A is taken as a vector quantity of magnitude equal to area and in the direction normal to it. The flux is positive when delta is lesser than 90 degree. The flux is zero when Q is 90 degree. The flux is negative when greater than 90 degree. The flux is maximum when is equal to 0 degree. The convention that electric field is equal to flux density at a point fixes the number of lines originating or terminating on a unit charge. Consider an isolated point charge plus Q. The lines of force from Q will spread uniformly in space around it radially, cutting the surface of an imaginary sphere drawn with the position of the charge as center. Normally at all portions, if r is the radius of sphere, flux density, number of lines originating from Q over surface area of sphere. The flux over the surface of a sphere or the number of lines originating from Q is equal to V. Therefore, see that if a unit charge is supposed to give rise to lines, the flux density at any point will give the intensity of field at that point.